Welcome to the Arithmetic Zone and welcome back to our Simple Java series. In the last part of this series, we essentially covered the basics of data types and variables in the Java coding language. And today we're mostly going to focus on the operators aspect of these variables. So let's begin. So much like in JavaScript and in other coding languages, we can do numerical operations and print them out to our console. So inside of here, what we can say is have 3 plus 5, and then when Java prints this out, well, 3 is classified as an int and so is 5, so it's going to try to add up these two integer values before it prints it out, and it's going to print out the number 8 right here. And obviously addition isn't the only operation available to us. We can also do subtraction, so 3 minus 5 should give us -2. You can do multiplication, 3 times 5 should give us 15, and division with the slash symbol. So, and I'm just going to change these to 3 divided by 2. So let's print all this out, and as expected, we get 3 plus 5 is 8, 3 minus 5 is -2, 3 times 5 is 15, but that last number, 3 divided by 2, now 3 divided by 2 is 1.5, but in the console right here, we had that the output is 1. 3 divided by 2 equaling 1 wouldn't really make much sense, but remember I said that these values, 3 and 5, are both integers, and in the last lesson we said that integers and decimals are split up in Java. Decimals are essentially referred to as the data type double, and if we ever need to represent a number in the form of a decimal, we should be using the double type. So, and when Java does operations on multiple integer values, the result is still going to be an integer. So 3 divided by 2, even though the answer should be 1.5, because these are both integer values, it's essentially taking the answer of 1.5 and then just removing and truncating anything that comes after the decimal point. So I could have this I can make this a different fraction that also results in a number that's not whole, like 1 divided by 2, and instead of 0.5, we're just going to get that the answer is 0 because it's just cutting off everything from the decimal point onward. So how can we fix this? Well, one way to fix it is by making one of the values a double, so just have 1.0 divided by 2. And now we have the answer is 0.5. Every time Java does a calculation, and if it involves at least one double, the answer is going to turn into a double as well. So no data gets lost here. When you divide a double by an integer, the result's going to be a double. If I make this 1 and make this 2.0, same thing should happen. You get the right answer of 0.5. What you can't do though is have them both be integers and expect the answer to be a double. The answer is going to be an integer, so just keep that in mind. And also, unlike JavaScript, there is no built-in exponential operator. So in JavaScript, something you could have done if you wanted to have exponents, so let's say 3 to the power of 2, you could have double asterisk signs like this, but this does not exist in Java. And if you want to deal with exponents, you have to use a math function, a built-in math function called math.pal, but we're going to get into that in a future video. Like JavaScript, instead of printing out values directly like this, what you can do is assign these compound values into variables and then print out the variables. So if we print out num, which is set to the value of 3 plus 5, it should just print out the number 8 right here. And the benefit of doing this is I can easily change the value of num without having to work with the inside portion of this print statement right here. So I can repeatedly change num however many times I want. So let's say I want to set num to 2 plus 3 instead of 3 plus 5. It's going to print out the most recent change to num. So now it prints out the number 5. So let's have it set back to 8. Let's modify the value of num based on what it already is. right now num is set to 8, but what if I want to add 2 to that value of 8? What I can do is say num is equal to num, which num is 8, plus 2. So now we're setting num equal to 3 plus 5, which is 8, and then we're setting num to the value of num, 8, and then add that by 2 for 10. So it should print out the number 10. And anytime you're dealing with this action of, setting a variable equal to the variable itself and then another operator, there's a shortcut we can use called the Unary operator, where instead of saying num is equal to num plus 2, you can just say num plus equals 2. And this is just saying add 2 to num, and this should give us the same thing as 10. And you can do this with any operation, not just with addition. So if you want to subtract 2, you can do that. You would get 6 because we have 8 minus 2 is 6. If you want to do multiplication, num times equals 2, this is basically saying let's double the value of num. So 8 times 2 results in 16. And then if you want to do division, if you want to have it, we can do it like this. Num divided by equals 2. So we're taking the value of 8 and dividing it by 2 for 4. And obviously 8 divided by 2 is a whole number. So we don't have to worry about any truncation there. We don't have to, change the value of any of these numbers into a double to accommodate for that error. On a special note, anytime you're incrementing or decreasing a value by 1 and only 1, there is another shortcut that you can use. So instead of saying num plus equals 1, what you can do is just say num plus plus. And that just says increase num by 1. So 8 plus 1 is 9. And this also applies with subtraction. So if you want to decrease it by 1, num minus minus, just like that. 8 minus 1 is 7. And again, this only works if you're increasing or decreasing a value by 1. Any other value, you're going to have to put in the plus equals sign if you want to modify the value based on that number. And just as a little PSA, just like in actual mathematics, you never want to divide a number by 0. So I have right here 8, and I'm basically dividing 0 by itself. So if I try to run the code, we get an error, an arithmetic exception error, division by 0. So you never want to divide by 0 in Java, just like how you would never want to divide by 0 in real life. So keep that in mind. Now I want to get into the topic of casting variables. So here we have a situation where we're setting a num, which is declared as the type double, which is a decimal number, and we're setting it equal to 5. But 5, like in this form, is just an integer. So when we print out num, what do you think is going to happen? Well, let's see. Prints out 5.0. Even though we assigned 5 to num, like 5 without the decimal point, it's still going to print out num with the decimal point, because when we pass an integer into a variable that's declared as a double, Java makes an implicit conversion of this 5 from an int to a double called a widening conversion, where it takes a number that takes up less space and it increases because it goes into a variable with more space. It's able to fill up that space with a decimal point. Now, do you think this would work if I were to pass in a decimal value as the value of a variable declared as an integer? Well, you can, as you can already see with the red squiggly line, well, that's not going to work. If we print it out, Java just gives us this strict error, type mismatch. You cannot convert a double to an int, even though you can convert an int to a double. And that's because we're passing a value with a larger data, with a larger memory space into a variable with less memory space, which would be a narrowing conversion, which usually wouldn't work. But there are ways to get around this, and we can do this by casting a variable. So next to this 5.0, what we can do is write in parentheses the type of the variable that we want to convert it to. So this is a double, we want to convert it to an int. So let's just write int right next to it. And now when we print it out, continue, we get the number 5. So we pass in the decimal value or the double value of 5.0. we're casting it into an int, so it loses the decimal point right here, and it just becomes 5, and then that's what's passed into num, and that's what we're printing out. Let's say if this was 5.5, if we cast that as an int, it's going to print out 5, not 5.5, because again, it's not really, you know, it's just getting rid of everything from the decimal point onwards. It's truncating the value. And this is how to get around errors involving narrowing conversions. Now here's a code segment of worthwhile interest. I'm printing out this value right here, a string that says the sum is, and then we're adding it to the addition between two integer values. What do you think is actually going to be printed out? Well, based on logic, you might think it's going to say, oh, it's going to print out the sum is 6, right? Because the 2 and the 4 add together to 6, and then it's going to combine 6 with the string and say the sum is 6. No. Instead, it prints out the sum is 24. Well, that makes no sense. How did that happen? Well, you see, the way Java sees this is that when you're adding a string to numbers like this, Java can't tell what the order of operations is. It's just going to add them left to right. So what it does, it's going to add the sum is and then the 2. So it's going to say the sum is 2. And then after it has that string, the sum is 2, it's going to add the 4 to that string as well to say the sum is 24. If we want to get over this issue, then we want to have Java, we want to be able to tell Java to do this part of the addition first, the 2 plus 4, and then we can do that just like in math class, where we can just write in parentheses to override the order of operations. So now, if we were to print this out, on the bottom it says the sum is 6 because Java adds the 2 and the 4 together to get 6, and then it adds the string and then the number 6 together. So essentially, when you're combining a string and a number, the result is going to be a string. So just keep that in mind when you're when you're concatenating these values like this. Usually it's from left to right, but if you're dealing exclusively with numbers, then it would follow the order of operations. Now to conclude this video, I want to go over escape sequences. And when you look into these 4 code segments before, which all print out the word hello as a string, you may notice these strange symbols that are colored slightly differently. So this is a backslash, and this is next to the hard bracket key on my keyboard. But every time you type in a backslash and it's inside of a string, so that means it's inside quotes, then you begin as an escape sequence. This is an escape character, and what the character that follows this escape character, so right here is quotes. Depending on what it is, it can do some special, it can have some special properties. So in the first case, I put in a quote after the backslash, and what that does is that basically I can just print out this quote right here if I try to print it, because usually you use the double quote to tell Java, hey, what I'm going to have inside here is going to be a string. If I try to remove this, you can see that this just turns into white text. It turns into a value that Java tries but can't recognize because it doesn't exist, because I use this quote right here to close off this quote with nothing inside. That's why we use the escape character whenever you want to include the quote as a part of the string. So let's print that out, and we get that it prints out hello with the double quotes. In the second part, I use the backslash, and then I write the letter N, and the letter N represents, the letter N after a backslash means new line. So when I print out hello with the backslash N, like in the middle right here, it's going to print out hell without the double L, not that L. It's going to print out that this string HEL. Then it's going to print out a new line. That's what the slash N represents, and then the remaining LO. So this is all technically one string. It's just that the slash N is telling Java to go on to the next line. The backslash T, this represents a tab, so basically a horizontal indent. So I have it in the beginning of this string, so before it prints out anything, Java is going to generate all this white space, and then it's going to print out the actual string of hello. And then in the final example, I just combined backslash N and backslash T one after another. So Java starts right here, right? It starts right here after this string because I use system.out.println, which automatically makes Java go on to the next line. So after going on to this next line right here from the \n, it then reads \t. So then it makes the horizontal tab. It then finally prints out the string right here, hello, after initially starting from this position, like right here. So that's a basic overview of escape characters, and that's going to be it for today's video. In the next simple Java video, I'm going to go more in depth in strings, which are definitely a special and unique data type in Java. So stay tuned for that, and I'll see you guys later.